This video is on nuclear chemistry particles. So nuclear chemistry looks at the nucleus of atoms. In the nucleus, we have protons and neutrons. We abbreviate protons as P positive because protons have a positive charge, and neutrons as N with a little zero next to it because neutrons have no charge. There are a few nuclear particles that we need to learn about, and they're going to be used to complete nuclear reactions. So when we write a nuclear particle, we have our symbol, and then we have our mass number on the top and our atomic number on the bottom. So we have a beta particle, which is 4,2 helium, or helium-4 atom. We have a beta particle, which is an electron, has 0 for the mass number and -1 for the atomic number of the protons. So it is just an electron. A gamma ray is an upside down Y. It kind of looks like that. It's kind of the upside down ribbon symbol. And that has 0 for my mass and 0 for my charge. I can draw these bigger for you to see here. Helium, beta, gamma. My positron is the opposite of a beta particle. This time it has a positive 1 next to it, so it's 0, 1, E. And then, so it's just like having a proton. And then a neutron is 1, 0, N. Okay. There are 3 main types of radiation that we're going to look at. There's alpha radiation. These consist of the biggest particles, so our alpha particles. They're the heaviest and the slowest. And to protect ourselves against them, we need clothes, just clothes and a sheet of paper would protect us. So they're so big they can't bounce through the paper. Beta radiation comes from beta particles. They're slightly smaller than our alpha particle, right? A beta has a mass of 0, where an alpha has a mass of 4. Our beta is just an electron. So here, they travel much further, and to protect ourselves against beta radiation, we just need a thin plate of wood or aluminum. Gamma radiation is going to be the smallest particle. In fact, gamma particles don't have mass or charge. There's nothing. It's actually just a light particle. They're the smallest with no mass, and they travel the furthest. To protect ourselves against gamma radiation, we would need thick lead sheets to do that. We have a word we need to know called transmutation. And this is where we use these alpha particles to change our nucleus in our elements. So it's a change in the number of protons or neutrons in the nucleus of an atom by absorbing or emitting a nuclear particle to create a stable nucleus. So usually a nuclear particle or radioactive particle does not have a stable nucleus, and so they're going to absorb or emit a nuclear particle to get there. So there's a couple of different types of nuclear reactions that we can learn about. We have natural radioactive decay, where a nucleus naturally absorbs or emits a nuclear particle to be stable. Or we have artificial radioactive decay, and this is where scientists will bombard a nucleus with a nuclear particle, so they'll force fission or fusion. Fission is where a nucleus is bombarded with particles, and that splits the nucleus into 2 smaller mass nuclei. So fission gets smaller. It goes from something really big into 2 smaller parts. Fusion is where 2 nuclei of small mass combine together to form a heavier one. So it's the opposite. Here I have 2 smaller ones come together to make a big particle. So fusion is 2 things fusing together, and then fission is 1 thing breaking apart. So radioactivity comes from unstable nuclei. An unstable nuclei is just, it's a singular form or a plural form of nucleus. So unstable nuclei would happen because there are too many or too few neutrons in the nucleus. Atoms with less than 30 protons need a ratio of 1 neutron to 1 proton. And atoms with greater than 30 protons need a ratio of 1.5 neutrons to 1 proton. When they do this, or when they don't have this ratio, they will absorb or emit a nuclear particle, and this will result in a stable nucleus.